We saw that elements cannot be clearly classified into metals and non-metals based on their physical properties. Will chemical properties help? Let's understand chemical properties of metals first. When we're looking at chemical properties of metals, there are a few things we will look at. We will see what happens when metals are burnt in air, when metals react with water, when metals react with acids, and lastly, when metals react with solutions of other metal salts. Now in all these four categories, there's just one simple thing we will do. We will look at how reactive the metals are. If the metals react easily, may it be with oxygen or air or anything else, we say that they are more reactive. When it's more difficult for them to react, we say that they are less reactive. Let's focus on the first category. Metals burnt in air. The most important points to note here is that almost all metals react with oxygen to form metal oxides. These metal oxides that are formed are usually basic, but they can also be amphoteric. What do we mean by amphoteric? Metal oxides which may show acidic as well as basic behaviors are known as amphoteric oxides. Most metal oxides are insoluble in water, but some may also dissolve to form alkalis. Okay, so metal oxides being formed in one thing, but do all metals react with oxygen at the same rate? Not really. Different metals show different levels of reactivity towards oxygen. Alkali metals such as sodium and potassium react vigorously with oxygen. In fact, they react even if they are just kept in the open, that is, at room temperature. They don't even need fire to ignite the reaction. What about the other metals? Metals such as magnesium, aluminium, zinc and lead also react with oxygen at room temperature, but they react a bit differently. When they react with oxygen, their surfaces get covered with a thin protective layer of oxide. This layer protects the inner part from being oxidized. What about iron? Iron doesn't burn on heating, but iron fillings burn vigorously after being heated. And which metals do we have at the end of the spectrum? Yes, silver and gold. Can you guess how they react with oxygen when burnt? Silver and gold do not react with oxygen at all. Yes, they don't react even at high temperatures. So we see somewhat of a pattern event amongst the metals. Sodium and potassium are more reactive, whereas magnesium is relatively less reactive. But wait, burning in oxygen doesn't really help us to decide about the reactivity of zinc, iron, lead or copper. All we know about these four is that they form a thin layer of oxide around the metals. So just this category of burning metals in air isn't enough for us to judge the order of reactivity of these metals. We can see a few more reactions to judge the order of reactivity. The same sample of metals to check out how they react with water. Don't forget our basic aim, to find out the order of reactivity of these metals. If a metal reacts more vigorously with water, then it is said to be more reactive than the one that doesn't react as much. In general, metals react with water to form metal oxides and hydrogen gas. And if the metal oxide formed is soluble in water, it will dissolve to further form metal hydroxide. So how can we judge the order of reactivity based on their reaction with water? We perform a simple task. First, we take a beaker half filled with cold water and see how the metals react with it. Some of the metals will react with cold water, but most of them won't. Out of those metals which didn't react with cold water, we try to add them to hot water and see how they react. Again, some will react with hot water and some won't. Those that don't react with hot water, we see how they react with steam. And that will kind of give us the order of reactivity. Ones which react easily with cold water are more reactive, and the ones which required steam to react are not as reactive. Metals like sodium or potassium react violently with cold water. In cases of these two metals, The reaction is so violent that the evolved hydrogen immediately catches fire. The equations look like this. This hydrogen catches fire immediately after the reaction. That's how vigorous the reaction is. So we know that sodium and potassium are very reactive. Remember, we're still talking about reaction with cold water. How does calcium react with cold water? Well, calcium does react with cold water, but the reaction is not as violent as what we'd seen with potassium and sodium. The heat is not enough for the hydrogen to catch fire. But what happens is that the calcium starts floating because bubbles of hydrogen gas formed stick to the surface of the metal. And magnesium? Does it react with cold water? No, it doesn't. But magnesium reacts with hot water to form magnesium hydroxide and hydrogen gas. And just like calcium, it starts floating due to the bubbles of hydrogen gas sticking to its surface. The remaining metals we see here don't react with hot or cold water. But aluminium, iron and zinc react with steam to form metal oxide and hydrogen. And the other metals like lead, copper, silver and gold don't react with water at all.